This is the EdExcel GCSE 9-1 Maths Paper 1, which is a non-calculator paper, and it's from the Specimen Set 1 papers. Question number 1. The diagram shows a right-angled triangle, so that's what we see here. All the angles are measured in degrees. We have to work out the size of the smallest angle of the triangle. So what we know already is that angles in a triangle sum to 180. So using the fact that angles sum up to 180, we have 7x plus 5x plus 18 plus the 90 degrees over here. All of this gives us 180 degrees. 7x plus 5x, that's 12x. 18 plus 90, that's 108. And the total here gives us 180 degrees. Now if we subtract 108 from both sides, 12x is equal to 180 take away 108, which is 72. And if we divide both sides by 12, x is equal to 72 divided by 12, which is 6. Now that we know what x is, we need to find out what the smallest angle is. Well, this angle here, of course, is 90 degrees. This angle here is equal to 5 lots of 6 plus 18, which is 48. And this angle here is equal to 7 times by 6, which is 42. You can see the 42 is the smallest angle. So 42 degrees is the smallest angle. Question 2. A box exerts a force of 140 newtons on a table. The pressure on the table is 35 newtons per meter squared. We have to calculate the area of the box that is in contact with the table. So here we've been given that pressure is equal to force over area. Now we know the pressure is 35, so we have 35 equals the force, which is 140, over the area, which we need to calculate. So if we work out what A is, you can see A is equal to 140 over 35, which is 4. So therefore, the area of the box is 4 meters squared. Don't forget the units. Question number 3. There are only red counters, blue counters, green counters and yellow counters in a bag. The table shows the probabilities of picking at random a red counter and picking at random a yellow counter. So you can see the probability of picking red is 0.24 and the probability of picking yellow is 0.32. The probability of picking a blue counter is the same as the probability of picking a green counter. We have to complete the table. Well, if the probability of picking a blue is the same as the probability of picking a green, we can call this unknown probability x. And we know that probability adds up to 1. So we have 0.24 plus x plus x plus 0.32. All of this is equal to 1. So if we tidy all of this up, we have 2x plus 0.56 equals 1. And if we subtract 0.56 from both sides, 2x is equal to 0.44, and therefore x is equal to 0.22. So we have 0.22 here and 0.22 here. Question number 4. A pattern is made using identical rectangular tiles, and what we have to do in this question is find the total area of the pattern. So, to find out the area of a rectangle, we need the length and the width. So here, we've got a length, we'll call the length L. And here, we've got a width, we'll call the width W. So here, we've got W. Here, we've got L. Here, we've got another L. We've got a W here. Now, if we take a look at this edge over here of the shape, you can see W plus L is equal to 7. So we have L plus W equals 7. We'll call this equation 1. And if we take a look at this edge here, you can see L plus another L plus W is equal to 11. In other words, 2L plus W is equal to 11. We'll call this equation 2. And if we subtract these from each other, so if we do equation 2, take away equation 1, you can see 2L take away L is equal to L. W take away W is equal to 0W. 11 take away 7, that's 4. So L is equal to 4, and knowing that L is equal to 4, when L is equal to 4, we have 4 plus W equals 7, and therefore W is equal to 3. So if we draw out one of these rectangles, you can see we have the width equaling 3, the length equaling 4, and therefore the area is equal to 12. So we have here 12 centimeters squared for one of these rectangles, and therefore the total area is equal to 4 times by 12, which is 48. So we have 48 centimeters squared. Question number 5. The diagram shows a sandpit. That's what we see here. The sandpit is in the shape of a cuboid. Sally wants to fill the sandpit with sand. A bag of sand costs £2.50. There are 8 litres of sand in each bag. Sally says the sand will cost less than £70. Show that Sally is wrong. Well, the first thing we need to do is find out the total volume of the sandpit. So therefore the volume is equal to 40 multiplied by 100 multiplied by 60. So if we work all of this out, we get 240,000 centimeters cubed. And of course, because here we are dealing with liters, we can divide this by 1000 to work out the volume in liters. So if we divide 240,000 centimeters cubed by 1000, we get 240. So the volume is equal to 240 liters. This is of this sandpit. And therefore the number of bags we need will be 240, that's the total amount of volume available in the sandpit, divided by 8, which is the amount of sand in each bag. So therefore you can see here we require 30 bags of sand. So we need to find out the cost of these 30 bags. So therefore, the cost is equal to 30, because we have 30 bags, multiplied by £2.50. So it turns out the cost is 75, which is greater than the £70 Sally is suggesting. So we can conclude Sally is wrong. Question 6. 4 friends each throw a biased coin a number of times. The table shows the number of heads and the number of tails each friend got. So we've got the number of heads here and the number of tails. The coin is to be thrown one more time. For part A, which of the 4 friends' results will give the best estimate for the probability that the coin will land on heads? Justify your answer. Well, what you can see straight away, Sharif has the best estimate because he had the greatest number of throws. And you can see that by taking a look at the total amount of throws he had. 120 plus 40 is 60. So Sharif will give the best estimate because he had the greatest number of throws. Now for part B, Paul says, with this coin you are twice as likely to get heads as to get tails. Is Paul correct? Justify your answer. Well, if we take a look at the proportion of those who get heads to those who get tails, let's take a look at each one separately. You can see for Ben, let's just write it down here. For Ben, you can see we have 34 heads to 8 tails, so we have 34 heads to 8 tails. If we take a look at Helen, Helen got 66 heads to 12 tails. If we take a look at Paul's attempt, he got 80 heads to 40 tails. And if we take a look at Sharif's, well, here we have 120 heads to 40 tails. And what you can see for each person, the proportion is different. So therefore, Paul is incorrect because the proportion of each person getting heads to getting tails is different. And you can see that from here. Now for part C, the coin is to be thrown twice. Use all the results in the table to work out an estimate for the probability that the coin will land on head both times. Well, you can see from here, the total number of heads we have, 34 plus 66 plus 80 plus 120, that's 300. So here we get a total of 300 heads, and the total number of tails, 8 plus 12 plus 40 plus 40, that's 100. So we have 300 heads, 100 tails. So therefore, the probability of scoring one head, this is equal to 300 over 400, which is equal to 3 over 4. So therefore, the probability of scoring a head twice, this will equal 3 over 4 multiplied by another 3 over 4, which is 9 over 16. So we have 9 over 16 as our probability. Question number 7, we have to write down for part A the exact value of cos 30. Well, cos 30 is the same as root 3 over 2. Now for part B, we're given this diagram here, and given that sine 30 is 0.5, we have to work out the value of x. So here, sine of an angle, in this case sine 30, is equal to the opposite x over the hypotenuse, 12. So we need to find out what x is. So therefore, x is equal to 12 sine 30. We know that sine 30 is a half. So we have 12 multiplied by 0.5, which is 6. So x is 6. Question number 8. The mass of Jupiter is 1.899 times 10 to the 27 kilograms. The mass of Saturn is 0.3 times the mass of Jupiter. For part A, we have to work out an estimate for the mass of Saturn. Give your answer in standard form. So first of all, we have an approximation for the mass of Jupiter. This is approximately 2 times by 10 to the power of 27 kilograms. And the mass of Saturn, this is 0.3 times the mass of Jupiter. So this will approximately be 0.3 multiplied by 2 times by 10 to the 27 kilograms. And if we work this out, we get 0.6 times 10 to the 27 kilograms. But we have to give our answer in standard form, and remember, for standard form, that's when our number is of the form a times by 10 to the power of n, where a is in between 1 and 10. So we want to have a 6 over here instead of a 0.6, and because here we've multiplied by 6, here we'd have to divide by 6, so we have 6 times by 10 to the 28 kilograms. Okay, so we have 6 times by 10 to the 28 kilograms. And now for part B, give evidence to show whether your answer to part A is an underestimate or an overestimate. Well, here we have an overestimate because we have rounded up. Question 9. Walkden Reds is a basketball team. At the end of 11 games, the mean score was 33 points per game. At the end of 10 games, the mean score was 2 points higher. Jordan says Walkden Reds must have scored 13 points in their 11th game. Is Jordan right? You must show how you get your answer. Well, here we have scores, we have means, and we have number of games played as well. So what formula we can use to help us with this problem is mean equals total amount over the number of games played, n. So if we rearrange from here, you can see the total is therefore equal to the mean multiplied by the number of games. So the total number of points, so let's just write this down, total score at the end of 11 games we have over here mean 33 multiplied by number of games 11. It turns out here we get 363, and at the end of 10 games, well, we've got here, if we score 2 points higher, then the 35, because we've got 2 more, times by 10, which is 350. And therefore, what we have is the difference between these is the number of scored points in the 11th game. So 363 take away 350, this is equal to 13 points. So therefore we can conclude Jordan is correct. Question 10. There are some red counters and some yellow counters in a bag. There are 30 yellow counters in the bag. The ratio of the number of red counters to the number of yellow counters is 1 to 6. For part A, we have to work out the number of red counters in the bag. So the ratio red to yellow, this is equal to 1 to 6. This is what we know so far. And we were told that there's 30 yellow in the bag. So we've got 30 here. So to go from 6 to 30, we would have to multiply by 5. So 1 multiplied by 5 is 5. And therefore, the number of red counters we have in the bag is 5. For part B, Reza puts some more red counters into the bag. The ratio of the number of red counters to the number of yellow counters is now 1 to 2. How many red counters does Reza put in the bag? So the way to think about this is the ratio of red to yellow is now 1 to 2. She puts more red, so the number of yellow stays the same as 30. To go from 2 to 30, we multiply by 15, and therefore 1 times by 15 is 15. And therefore, the amount of red counters she put into the bag, we have 15, which is the amount of red counters now, minus the 5, which is the amount of red counters before, which is 10. So she put 10 red counters in the bag. Question 11, we have to write down the value of 125 to the power of 2/3. Well, this is the same as raising 125 to the power of 1/3 to the power of 2. And of course, multiplying the third by 2 gives us 2/3. Now, when we raise something to the power of a third, this is the same as cube rooting. So cube rooting 125 and then squaring it, we get here 5 squared, which is equal to 25. So 125 to the power of 2/3 is equal to 25. Question 12. Sean drives from Manchester to Gretna Green. He drives at an average speed of 50 miles per hour for the first 3 hours of his journey. He then has 150 miles to drive to get to Gretna Green. Sean drives these 150 miles at an average speed of 30 miles per hour. Sean says, my average speed from Manchester to Gretna Green was 40 miles per hour. Is Sean right? You must show how you get your answer. Well, of course here, because we're thinking about speeds and distances and times, the formula connecting all those is speed equals distance over time. So we have speed, which is equal to distance over time. Now, in this question, you can split this up into 2 parts, the first part of the journey and the second part of the journey. So for the first part of the journey, we've been given a speed, we've been given a time, so we can find out the distance he travels. And then for the second part of the journey, we can find out the time it takes to travel the 150 miles, because we've been given an average speed and we've been given a distance as well, 150 miles. And with this we can find the total distance, the total time, and then from that we can find the average speed. So, for the first part of the journey, the distance is equal to the speed, 50 miles per hour, multiplied by the time, 3. So therefore the distance is 150 miles. For the second part of the journey, the time will equal the distance, 150, over the speed, 30. So therefore the time is 5 hours. So therefore the total distance is equal to 150, which we found here, plus the 150 given here. So the total distance is 300 miles, and the total time that will equal the 3 hours for this part of the journey plus the 5 hours for this part of the journey. So we have 8 hours. And therefore, the average speed is equal to the total distance, 300, divided by 8. So here, we can simplify this and then compare it with the 40 miles per hour. So if we divide top and bottom by 2, we have here 150 over 4, which we can simplify to 75 over 2, which is 37.5. So its average speed is 37.5 miles per hour, and this is less than the 40 miles per hour as suggested here, and therefore we can conclude it's incorrect. Okay. Question 13, we have m, which is equal to the square root of k cubed plus 1 over 4. Well, over here, first thing we need to do is recognize that we need to undo the square root. So we have m squared equals k cubed plus 1 over 4. And if we multiply through by the 4, 4m squared is equal to k cubed plus 1. If we subtract 1 from both sides, you'd find k cubed to equal 4m squared minus 1. And if we cube root both sides, k is equal to 4m squared minus 1 cube rooted. So therefore, we have k equals 4m squared minus 1 cube rooted. Question number 14, we have to solve x plus 2 over 3x plus x minus 2 over 2x equals 3. Well, first thing we can do is combine the fractions on the left hand side, and if we do that, we've got 2x multiplied by x plus 2 plus 3x lots of x minus 2 over 3x lots of 2x, and this is all equal to 3. If we now multiply through by the 3x and the 2x, we would have 2x lots of x plus 2 plus 3x lots of x minus 2 equaling 3 lots of 3x lots of 2x. So, if we expand and simplify, 2x times by x, that's 2x squared, 2x times by 2, that's 4x, 3x times by x, that's 3x squared, 3x times by minus 2, that's minus 6x, and this is equal to 3 times by 2, which is 18, and then we have the x squared. So if I tidy up the left hand side, you'd find we have 5x squared minus 2x equals 18x squared. Simplifying by taking everything over to one side, we have 13x squared plus 2x equals 0. And if I factorize, we've got x lots of 13x plus 2 equals 0. So either x is equal to 0, or we have 13x plus 2 equals 0. Now, of course, x cannot equal 0, and the reason for this is otherwise we'd be dividing by 0. So we cannot divide by 0. So therefore, the only solution we have is x equals minus 2 over 13. So we have x equals minus 2 over 13. Question 15, we have to show that 2x squared minus 3x minus 5 over x squared plus 6x plus 5 can be written in the form ax plus b over cx plus d, where a, b, c and d are integers. Well, let's first of all concentrate on the 2x squared minus 3x minus 5. We require two numbers which multiply to give 2 times minus 5, which is minus 10, and which add to give the minus 3. You'd find these two numbers to be minus 5 and 2. So we can rewrite the minus 3x term in terms of what we've just found here. So we have 2x squared plus 2x minus 5x, so minus 5x minus 5, and if we group the terms together, we have, well, if we first of all factorize, we've got 2x lots of x plus 1 minus 5 lots of x plus 1, and if we group the terms together, you'd find we have 2x minus 5 lots of x plus 1. Now, if we deal with the x squared plus 6x plus 5, we require two numbers which multiply to give 5 and which add to give 6. So therefore, we have 5 and 1. So therefore, we have over here x plus 5, lots of x plus 1. So now we can tidy all of this up. Of course here, if we write out our fraction, 2x squared minus 3x minus 5 over x squared plus 6x plus 5 is equivalent to, well, here we have 2x minus 5 lots of x plus 1 over x plus 5 lots of x plus 1. And you'd find here the x plus 1's cancel on the top and the bottom. So we are left with 2x minus 5 over x plus 5. Question 16. These graphs show four different proportionality relationships between y and x, and we have to match each graph with the statement in the table below. So y is directly proportional to x. Well, this means y equals x, and that corresponds to graph D. Y is inversely proportional to x. Well, this means y equals 1 over x. So this corresponds to graph A. Y is proportional to the square of x. So that means over here y equals x squared, which corresponds to graph B. And y is inversely proportional to the square of x. This is y equals 1 over x squared, which corresponds to graph C, as we see here. Question 17. PQ, that's this length here, is equal to PR, which is this length here. S is the midpoint of PQ, and T is the midpoint of PR. We have to prove that triangle QTR is congruent to triangle RSQ. So first of all, if PQ is equal to PR, that's given, that means that the triangle PQR is isosceles. And if that's the case, then PQR, the angle PQR, this one, is equal to the angle PRQ, this one here. So let's just write that down. So PQR, that's this one, equals PRQ, and that's because base angles in an isosceles triangle are equal. Now, we can also see that TR is equal to SQ, so this length here is equal to this length here, and that's because they are the midpoints of PQ and PR respectively. So TR equals SQ, and that's because S and T are the midpoints of PQ and QR respectively. And what you'd also find is, if we think about which triangles we want to show are congruent, we want to show that QTR and RSQ are congruent. Well, you can also see that those triangles share QR. So they share this length here. Okay. So the triangle QTR and RSQ share QR. And therefore we have the side angle side relationship, and therefore we have congruent triangles. Question 18. The diagram shows a solid semisphere, and we've been given that the volume of a sphere is 4/3 pi r cubed, and the surface area of the sphere is 4 pi r squared, and the volume of the hemisphere is 250 pi over 3, and we have to work out the exact total surface area of the solid hemisphere. Give your answer as a multiple of pi. So we know that the volume of a hemisphere is half the volume of a sphere. So the volume of a hemisphere, so volume of the hemisphere, we have over here 1/2 lots of 4/3 pi r cubed. So if we work this out, we have 2/3 pi r cubed. And we know that this 2/3 pi r cubed is equal to 250/3 pi. Now, if we find out the radius, we can use that to find out the surface area of the hemisphere. So, you'd find the 3's cancel and so do the pi's. So, we have 2r cubed equals 250. R cubed is equal to 125, and therefore r is equal to 5 centimeters. So with this we can find out the curved bit of the hemisphere, so the surface area of the curved bit, this is equal to, well, it's going to be equal to 1/2 of the surface area of a sphere. So we're going to have 1/2 lots of 4 pi r cubed, which is 2 pi r squared. Okay, so this should be squared. So therefore, this will equal 2 pi lots of 5 squared, which is, I'll just write it down here. So this is equal to, I'll just write it down. We've got 2 pi r squared. So we've got 2 pi lots of 5 squared, which is equal to 50 pi. And the area of the circle, this is equal to pi lots of 5 squared, which is equal to 25 pi. Okay, and don't forget the units. So therefore, the total surface area is equal to the 50 pi plus the 25 pi, so we get 75 pi centimeters squared. Okay, so we have 75 pi centimeters squared for the surface area of this shape. Question number 19, we have to simplify fully 6 minus root 5 lots of 6 plus root 5 over root 31. So if we work this out, well, you can see on the top we've got a difference of 2 squares, but we'll show the working out fully. We've got 6 times by 6, that's 36, and then we've got 6 times by root 5, which is 6 root 5, and then we've got minus root 5 times by 6, so here we've got minus 6 root 5, and then we've got root 5 times by root 5, which is just 5. And on the bottom we've got the root 31. Okay, so if we tidy this up, well, 36 minus 5, that's 31. So let's just move this here actually. Let's just straighten out this line. So here we get 31 over root 31. Okay, and what we need to do now is multiply both the top and bottom by root 31. This process is called rationalizing the denominator. So here we've got 31 over root 31 multiplied by root 31 over root 31. So if we work this out, we've got 31 times by root 31 over 31 square rooted times 31 square rooted, which is 31. Well, here these cancel out, so we're left with root 31. So we have root 31. Question 20, we have to prove algebraically that the sum that the difference between the squares of any two consecutive integers is equal to the sum of those two integers. So first of all, let's concentrate on what we mean by consecutive integers. Well, here, an example, if an integer is n, the consecutive integer after that will be n plus 1. And what we need to find here is, first of all, the difference between the squares of these. So we have n plus 1 all squared minus n squared. So this is the difference between the squares. Okay? So now if we tidy this up, we've got n squared plus 2n plus 1 minus n squared, which is the same as 2n plus 1. And the sum, that will equal n plus 1. Okay? So this is the sum of these two integers, as we see here. Okay? So if we work this out, we've got 2n plus 1. And because these are equal, we can conclude we have shown the proof. Question number 21. There are 10 pens in a box. There are X red pens in the box. All the other pens are blue. Jack takes at random 2 pens from the box. We have to find an expression in terms of X for the probability that Jack takes 1 pen of each colour. Give your answer in simplest form. Well, if we have X red pens, that means from here we can conclude that the number of blue pens is equal to 10 minus X. Because there's 10 pens in total, X are red, so the number of blue is 10 minus X. Now, here we can draw a tree diagram. So let's just quickly show the branches. So here are our branches. Now, originally, we have 10 in the box. Okay? So we've got 10 pens in the box. And of those 10, X are red, and the rest, we've got 10 minus X, which are blue. Now, if we take a pen from the box, the remaining number will be 9. Okay? So we will have 9 pens remaining if we take one out of the box. So, if we take one red, given that we take a red, the number of red will remain as X minus 1, but the blues will remain the same as 10 minus X. And if we take a blue, given we take a blue, there will be 9 minus X remaining, and the number of red stays the same as X. Okay? So, with that, he takes a pen of each colour. That's what we were told in the question. Well, that's what we need to find out. The probability that he takes a pen of each colour. So, we need to find out the probability that it takes a red, then a blue, or probability that it takes a blue, then a red. So let's work this out. Red, then blue. That will be X over 10 multiplied by 10 minus X over 9. Or, so if I rub this up, we have 10 minus X over 10 multiplied by X over 9. Okay? So now we need to tidy all of this up. So here we're going to have, if we simplify here, we're going to have 10x minus x squared over 90 plus 10x minus x squared over 90. So we now need to simplify all this. So we've got, if we write them over a common denominator of 90, we have 10x plus 10x, which is 20x, and then we've got minus 2x squared, and then on the bottom we've got the 90. And if we simplify all this, it turns out we get 10x minus x squared over 45. So this is our final answer. So we have 10x minus x squared over 45. Question 22. CAYB is a quadrilateral. CA is equal to 3a, that's what we see here. CB, that's 6b, and BY is 5a minus b. X is the point on AB such that the ratio AX to XB is 1 to 2. So what this means is somewhere here we have the point AX to XB, so somewhere here we've got the point X, and the ratio of AX to XB is 1 to 2. And we have to prove that CX is 2/5 of CY. Well, let's see, can we calculate CY directly? Yes, we can. CY, that's equal to CB plus BY. So CB, that's 6B, and then BY, that's 5A minus B. So we have 5A minus B. And if we tidy all this up, you can see we get 5A plus 5B. Now we need to find out what CX is. Well, before that, we need to find out what AB is, and from that we can find out what AX is given this ratio. So AB, this is going to equal AC plus CB. Well, AC, that's going to be minus 3A, and then CB, that's 6B. So this is AB. And therefore, AX, that's going to equal, if we use this ratio here, that's going to equal 1/3 AB. So 1/3 of minus 3A plus 6B, that's going to equal minus A plus 2B. So now we can find out what CX is, starting at C, finishing at X. CX, that's equal to CA plus AX. So we have CA, which is 3A, and AX is minus A plus 2B, which is 2A plus 2B. In other words, what you can see here then is CX, which is 2A plus 2B, that is indeed equal to 2/5 lots of CY, which is 5A plus 5B. So therefore, CX is equal to 2/5 CY. Hence, we've shown this statement to be true. Question 23. We've been given this diagram, and we have to find an equation of the line that passes through the point C that is perpendicular to AB. So what do we have to find out? Well, we want a line that's perpendicular to AB but passes through C. So essentially the line we want is, if I just show this in red, we want this line here. Okay, let me just show it more neatly. We want, if we show this line here. Now, let's think about how we can do this. Well, first of all, we need to find the gradient of AB. From that, we can find out the gradient of this line here in red, because these are perpendicular to each other. So first of all, A has coordinates -2 across 0 up, and B has coordinates 0 across 4 up. Okay, so let's just show that here. We have 0, 4 for the coordinates of B. So therefore we can find the gradient of AB. So we've got the change in y, 4 take away 0, over the change in x. Change in x is 0, take away -2. So therefore the gradient is equal to 2. And therefore the perpendicular gradient, that's going to equal -1 over 2. And now we need to find an equation through the point C. So if we use the coordinates of C with coordinates 5, -1, using y equals mx plus c, so let's just write this down. We will be using y equals mx plus c. We have y, which is -1. This is equal to m, which is -1/2, lots of x, which is 5, plus c. And we need to find out what c is. So we've got -1 equals -5 over 2 plus c. And if I add 5 over 2 to both sides, you'd find c to equal 3 over 2. And therefore, we can conclude we have y equals m, so that's -1/2 x plus c. So we have y equals -1/2 x over 3 over 2 plus 3 over 2. So we have y equals -1/2 x plus 3 over 2.